Good morning, good afternoon, and good evening. Welcome to this third training of our series following the UN Austria Symposium on space application for climate action. So we are now ready to start, and today we will hear from the European Centre for Medium Range Weather Forecast. Chris Stewart is here with us. He's going to give us a live training for 1 hour, and he's going to tell us all about the Copernicus Climate Change and the Atmosphere Monitoring Service. To follow the training most effectively, if you haven't done so, please remember to register with the Climate Data Store and with the Atmosphere Data Store before we get started, so you might still be able to do this in the next few minutes. My colleague Shini is taking care of the chat, so if you have any questions, any comments, please type them in the chat and then we will just take care of this. There will be 3 parts in the training and we will take care of the question at the end of each part. And now I give the floor to Chris to get started. Thank you very much.
Thank you very much, Natalie. And I'm very happy to see you all, albeit virtually. So my name is Chris Stewart, and I am the training coordinator at the European Centre for Medium Range Weather Forecasts. And I'm very happy to guide you in the next hour through some training practicals related to the Copernicus Climate Change Service and the Copernicus Atmosphere Monitoring Service. So the way the training will be structured, first I'm going to provide an introduction to Copernicus and the services. Then I'm going to focus on the Copernicus Climate Change Service for the next 20 minutes, and then the Copernicus Atmosphere Monitoring Service, including, what the services provide and the training materials available. And then we can have a 20-minute Q&A. So that's the way the training will be structured. So I'm just going to start by introducing Copernicus. So Copernicus is the European Union Space Programme. And it's the European Union Earth Observation Programme, I meant to say, which is part of the space programme. And this Earth Observation Programme includes satellites called the Sentinels that are orbiting around the Earth, and they're acquiring data about the Earth's atmosphere, oceans, land, climate, through a number of different sensors. And these are constellations of satellites that provide long-term continuity for services, for academic users, for anyone who wants to make use of the data. There's also an in-situ measurement component, and then there's a services component. And ECMWF is entrusted with 2 of the services, so the one related to climate change and the one related to atmosphere monitoring. So what I'm going to do now is I'm going to share my screen. And I'm going to explain to you a little bit more about the Copernicus Climate Change Service. So can you all see my screen? I hope that
yes.
Okay, perfect, great. So this is the homepage of the Copernicus Climate Change Service, or C3S for short, because it's like 3 C's, Copernicus Climate Change. So the homepage is very easy to find. You can just do a Google search for Copernicus Climate Change and you will find it. So C3S provides authoritative information about the past, present and future climate. It also provides tools to enable climate change mitigation and adaptation strategies by policymakers and businesses. So this is the kind of this is the mission statement on the homepage of C3S. And if you scroll down the homepage, you will see that C3S provides different types of services. So every month it provides high-level information products, such as the climate bulletins every month on the state of the climate, and once a year a European state of the climate. but it provides global data. So it provides high-level information products. It also provides data, and we're going to look at this data in a little bit more detail, how you can access it and how you can process it. It also provides thematic data and information products. So this is the data in action. And then there are a number of use cases, case studies, user stories, and there are also tools in the form of a toolbox to help you process the data. So this toolbox is currently undergoing a change. There'll be a new version of the toolbox. So I'm not going to focus too much on the toolbox. But what I'm going to do is I'm going to show you how to access the data and how to work with the data. So C3S is an operational service. So this means that it doesn't just provide data, take it or leave it, with no information and no support behind it. There is also a comprehensive evaluation and quality control behind all the data sets. And there is also a very good user support service and a training service. So these are all accessible through the website. If you go to help and support, here you find the user support information. There's documentation center. There's a virtual assistant. Basically, the user support works in 3 steps. First, there's the virtual assistant, which is a robot you can speak to. But if you don't find the information there, you can go to the forum and the knowledge base, where you have a lot of documentation. And then finally, if you don't have the answer to your question, you can raise a ticket with the service desk. So here you can raise a ticket with the service desk. Then here we have the training section, which I'm going to look at in more detail as well. I just want to scroll back up to the top of the page. And I want to speak a little bit about the data. So if you see on the top of the page, wherever you are, you will find a link to the data. So if you click on that link, this takes you to the catalog. Now, this is like the bedrock of C3S. So here you find petabytes of climate data, and there are different types of climate data available, and we're going to have a little look at the different types of climate data. So before this training, you're given homework, which was kind of optional homework, but it was just designed to stimulate you to have a look at the website and to get started. And the homework was just to log in or register with C3S. So everything is free. You can download data, you can search for data, you can download the data from wherever you are in the world. The only reason to register, and you can even actually go to the catalog and search for products without registering. But if you register, and it's a very simple registration, you just have to go to create a new account, you just have to put in your email, first name, surname, country, sector. Okay, I think, and then you just have to create a new account and you get an email, and then you're registered with C3S and you can log in. And the reason why it is good to log in is because then you can actually download the data. So if we log in here, then we can see that my name appears here. So to access the catalog, you can put in keyword search here, or you can just click on search and you'll find everything. And here you'll find applications and data sets. So data sets are the kind of, that's the main data that's available. I mean, this is the main, let's say, the meat of the service. And applications are built on this data. So applications are high-level web-based applications that allow you to view the data, view graphs, plots, even download some data, look at maps, time series, and these are for specific topics. So these applications provide some value adding on top of the data and give you some high level information products. These are often quite specific. So if they don't meet your needs, you're encouraged to use these applications as templates, which can be modified to suit your needs. And I'll give you an example of that. If we go to one of these applications, so this is the global temperature trend monitor, okay? And what you can do is you can look at the source code of this application. So this is the source code. Now this is written in a what we call the CDS toolbox language, which is basically you know, a wrapper for Xarray and for Python libraries. And you can take that, you can copy that to a clipboard. You can go to the toolbox, okay, the toolbox editor, and you can copy it into the toolbox, and you can work on it. Now, I'm not going to look at this in any detail because this environment is going to change. So this is at the moment a closed environment where you can work with the data, and you're very close to the data, so you don't actually need to download it onto your computer. But this will change to be more open to allow you to use your own libraries and to hopefully also incorporate your own data to work also with the C3S data. But it'll work in much the same way, in the sense that you'll have an environment where you can process that data. So I'm just going to go back to the CDS, the climate data store. So these are the applications, but as I mentioned, the bedrock of C3S are really the data sets. And here you find a long list of all the data sets. So these are just listed in not a particularly structured way. It's just a long list of all the data sets that we have available. And these are data sets from the past, present and future climate. And you can use the filters here to filter certain products. Now, when I say past, present and future climate, we have different types of data sets. So when we say data sets from the past, these include observations. So from satellite observations or in situ observations, but they also include reanalysis. And reanalysis are a combination of observations assimilated into models that fill in the gaps in space and time of the observations. So basically, they provide a consistent data set using the state-of-the-art forecast model to create a consistent global time series from several decades into the past up to the present. And this is very good for analysis of the past climate and to calculate climatologies, so for the last 30 years or even further, and then to use that climatology to identify anomalies in particular times. So you can see if, for example, a heat wave is really a significant heat wave. Is it hotter than ever recorded before? Or is it just is it within the range of expected values? So the reanalysis data sets provide a consistent data set from the past. We also have analysis data from the present. So, you know, taking observations and again, filling in the gaps in the observations. And we provide forecast products. So forecasting into the near future, seasonal forecasts, looking at the next season, and then also projections, climate projections, projecting up until the end of the century. And of course, the projections are not really considered forecasts. They're more projections of how different variables may look according to different scenarios. So these can be filtered here. So you can look at product types, climate indices, climate projections, satellite observations, reanalysis, and so on. You can also filter by spatial coverage, European datasets or global datasets. And all of these datasets, whether they're from the past, present, or the future, they're datasets of basically of essential climate variables, so different variables that characterize the climate. or there may be climate indices, so combining different variables to provide some kind of an indicator. And this data is, most of it is gridded, so it's very easy to work with, and it's usually in GRIB or in NetCDF format. So when you see the list of datasets here, so let's go to one of the typical datasets. Let's go to reanalysis, and we filter through the reanalysis datasets. So you can even put in a keyword. So one of the flagship products of ECMWF is the ERA 5 reanalysis dataset. This is the ECMWF reanalysis version 5. So here you find a list of the ERA 5 related datasets. So if we look at this data, you can see that this is broken down into different data. So sometimes the data is available at hourly resolution, sometimes monthly averages. So if you look at the ERA 5 land monthly average data from 1950 to present, for example, so this is high resolution over land, but we also have global data. So for each data set, you'll see an overview of that data set. It provides a summary description, and it provides a description of all the variables in the data set. So here you find a lot of different variables for wind, for temperature, evaporation, lake ice depth, leaf area index. So a very huge list of these variables, and you'll find the units of each and a brief description of each one. Then if you go to the download data tab, okay, well first you can also see quality assessment. So this is the quality, the evaluation and quality control segment, where you can find the data about the quality assurance. Then you find the full documentation here. So any information that's not already in the overview tab, if you go to the documentation, you'll find the full description of that data set. And then finally, the download data enables you to actually download the data. So here you can specify the parameters of your download. So here you can select the monthly average reanalysis or monthly average reanalysis by hour of day. Here you can find all the different variables that you may be interested in. So you may be interested in evaporation for the top of the canopy. Let's look at a typical variable, 2 meter temperature. Then here you can specify the year. You can select, you can clear everything, or you can select specific years, or you can select all. Then here you see you can select all the months, or you can only select if you're only interested in one particular month. Let's say you want the summer, so June, July, August. You can select those months. And then here you can also specify a subset region, okay, or you can select the whole area, the whole globe. And then finally, to download the data, if you select submit form, or you can also select the format, so GRIB or NetCDF. NetCDF is a common format that most people prefer. And you also have to accept the terms and conditions if you're downloading this data for the first time. So it's just a checkbox you have to select. Here it's already selected because I've already done this. And then finally, if you just select submit form, it'll download the data. So first it'll queue it, okay, it'll be queued, and then finally you'll see the download link. Normally it doesn't take very long. You can see here, last time it only took me 2 minutes to download the data. So that's one way you can access the data. Another way to access the data is to download it programmatically. So this, if you don't want to always go to the website, select the different checkboxes and then click the button to download the data. Let's say you want to programmatically iterate through the different variables or different time ranges or different geographic areas, then instead of downloading everything, because this is a huge data set, so if you select every single parameter and every single time range, for the whole world, then it won't work because it's just too much data. So what you can do is you can iterate through different segments of this data set, and you can do that programmatically if you click on Show API Request. So this is an API that contains a block of code that you can copy and you can paste into a Python script. And you can download this using the CDS API. So the CDS API is something that needs to be installed. It's an API that enables you to access this data programmatically. And what I'm going to do now is just to show you some tutorials we have that explain how you can use the CDS API to download the data programmatically and to work with that data using Python. These tutorials are entirely self-explanatory. You can do them at home. They're completely open and free. So you can take them, you can use them as templates, you can modify them to your own needs. And now I'm going to show you where you can find them. If we go to home, if we go back to the home page of C3S. So this is the home page of C3S. Okay. We go to help and support. And we scroll down to training. Go to training. And then here you can find Jupyter notebooks. Okay, so these are in the form of Jupyter notebooks. We also have e-learning modules here. E-learning modules are just, they don't include any practical, well, they do have some practical guides as well, but they're in the kind of, format where you can see different pages and you can look at videos and read text, and it tells you more about the different types of data that we have. But these Jupyter notebooks provide practical instructions on how to process that data. So this is a catalogue of Jupyter notebooks, and the way you use these, okay, so here you can see they're categorized according to the different climate data types. So we have reanalysis tutorials, tutorials on climate projections, tutorials on seasonal forecasts, and then this is a link to tutorials from the Copernicus Atmosphere Monitoring Service, which we're going to have a look at as well. So these Jupyter Notebook tutorials provide practical guides. So if we click on one of these, for example, you will see a practical guide on how to calculate climatologies using climate data from C3S. And you can run this tutorial in the cloud. So you don't have to install Python, you don't have to install anything on your own computer. You can just click on one of these links. So for example, Binder, let's open in a new tab. So Binder will create an environment in a Docker container where you can run the tutorial, including downloading the data and doing any analysis on that data. Also, Kaggle is another cloud provider. So Kaggle also brings up the tutorial and enables you to go through the different steps of the tutorial. So we're going to have a quick look at this now. So Binder will take some time to load. It needs to create the environment. I think Kaggle is a bit quicker, so let's just use Kaggle. So remember, this is just a free cloud service provider. Now Binder is also ready. Okay. So here we have the Binder that's loaded. Okay. So here you can run. So what you find is text in Markdown in an HTML, and then you have these blocks up here, which are code blocks. So to run a code block, you just have to go to the play icon, or you can press Shift Enter or Control Enter. So Shift Enter will run this, or if you just click on play, it will run this. So this first code block is just to install the CDS API. Okay. The second code block is to import some libraries. So we run this as well. And when that little star turns into a number, then you know that this cell has finished. You see now it has turned into 2, so this cell has finished running. Then here, once you have, so to download the data, to download the data, you need to go to a page of the climate data store, where you have your API key written. So everyone who has registered with the Copernicus Climate Change Service automatically is given an API key. Okay, and that key you can find on this page here. I'm not going to click on that page, because if I click on that page, then you'll see my key, okay, which is a secret key. But if you have registered and if you click on that link, then you will find your key appearing, and that key will have a certain number of digits. Then I think it'll have maybe a colon, then it has certain letters separated by some hyphens. This is more or less how it looks. Okay, it looks something like this. So then we run that to insert our key. This is just an invented key now, but you would put in your real key. And then you continue running these code blocks. So this, as if you remember, this was the script that you find when you select Show API Request in the catalog data download page. So this is the data download request that if you now run, okay, if you run this, I'm not going to run it now because I haven't put in a real API key, but if you run this, then it will download the data. And then you can run these different code blocks to view the data. So this code block here just reads the data in netCDF format into Xarray, into an Xarray object, a data set. So Xarray is a Python library for working with multi-dimensional arrays, such as climate data in netCDF format. And when you read the data, you see the characteristics here. So you see it has different dimensions of latitude, longitude, and time. In this case, it's a data set of 2-meter temperature, as written here. Then we can perform certain calculations on this data. So here we convert so the data, sometimes by default, it comes in a 0 to 360 degree grid. We want to convert that to plus or minus 180 degrees. So we run these code blocks to do that. We can change from Kelvin to Celsius, the temperature units. Then we can plot the data. You can see there's a very simple plotting function here in Xarray. It's just one line. You just plot the data for whichever time step you're interested in. And then this section shows you how you can calculate climate normals. So this is the climate, the average climate for a certain period, in this case a 30-year period. And then this shows you how to calculate the anomaly of a particular time step with respect to the climatology. So you see if a particular a particular date was normal or abnormal. So this is a plot of the temperature anomaly with respect to climatology for a particular time. So this is the 2016 average anomaly with respect to the 1991 to 2020 mean. And then this shows you how you can calculate monthly climatologies. So for a particular month, let's say you want to see all of the Septembers for the last, I don't know, 50 years. I want to calculate the average of all the Septembers, and then I want to see if this September was abnormal compared to the September climatology. And this shows you how you can do that. So again, this is completely free to you. You don't need to install anything here. You can just run these, just press play and you run these different code blocks. The only thing you need to do is to register with the CDS and obtain an API key, which you find freely available on that page. Okay, then you can programmatically, or even not programmatically, you can even download the data using the web form, and then you can run these programs on that data. So these are just scripts which you can take and you can modify as you wish. So they're completely, free. You can change any of these things here. Okay, you can really change if you want to change a date range. let's say, just give an example here, for example, you may want to, so instead of calculating the 1991 to 2020 climatology, maybe you want to calculate the 1981 to 2010 climatology. Okay, you can change the dates here, and you can run, you know, you can change it as you wish. Even the text here, this is all text in Markdown. If you want to create your own tutorials for your own pupils, you can change the text. Okay, you can entirely modify anything. So the whole philosophy behind Jupyter is to promote open source and free science. So you can use these as guidelines to do your own processing. And these provide some examples. So let's say here you calculate the monthly climatology. You can look at the monthly climatology here, a very simple plotting command, or a slightly more complex plotting command using matplotlib if you want a bit more customization. Here you also look at see the standard deviation. Okay, here if you want to do a time series analysis, now in this section of the tutorial we're looking at the Arctic, and we look at a time series. Okay, if you look at the Arctic, the full time series, you don't notice any difference over time, but if you look at the yearly means, you see a very strong increase over time in temperatures, because here you have the full seasonal cycle, so you have a huge variation in any given year in temperature. But if you look at the yearly averages, you obviously see a very clear trend. And if you look at the anomalies, the temperature anomalies in a typical kind of bar chart, similar to what you see in the monthly bulletins, the high-level information products available from C3S. And here we look at the differences in different seasons, winter, spring, summer, and autumn, to see how the trend varies. So this is an example of one Jupyter Notebook-based tutorial. We have many of these on the website. So you'll see we have tutorials that work with reanalysis data from the past. So we have tutorial on climatologies. We have a tutorial on climate indices, how to create an index from multiple variables, such as the thermal comfort index, wind chill, or many different types of indices you can calculate from a single variable, from multiple variables. And then here we have a case study analyzing a heat wave using reanalysis data. So to see if strong temperatures identified at a particular time, how significant they were when comparing it with the climatology. Then we have tutorials on climate projections. So if you click on this, you can see what these are about. So in this tutorial, we plot an ensemble of CMIP6 climate projections. And if I just scroll right down to the bottom of this tutorial, you can see that the tutorial is to recreate this plot here, which shows the projection of, in this case, global average temperature from the past, from the historical period, right up until the end of the century, according to different SSPs. Okay, so that's what this tutorial shows. Then we have a tutorial working with regional projections, sorry. So these are higher resolution, not global projections, but regional projections. So we have them for Europe, for the Arctic, for Africa. And in this case, we're looking at the African Cordex. So this is the Delta method, looking at the historical climatology and compared to the future climatology. So for the 30 years 2071 to 2100 compared to the 30 years 1971 to 2000. So one minus the other to see the difference between the two. You can see that in the future here it's likely to be much hotter in certain regions, according to these particular models. Then we have tutorials on seasonal forecasts. So we have one at the moment, but another one will be published very soon. So this particular tutorial shows how to calculate seasonal forecast anomalies, which, by the way, are also available as separate data sets. But This just shows you how those data sets are created. So this is just an overview of the tutorials we have for C3S. I think what I'll do now is I'll go over to CAMS, the Copernicus Atmosphere Monitoring Service. And by the way, the tutorials for the Copernicus Atmosphere Monitoring Service are available at this link here as well. So this is what we call a Jupyter book, which contains a catalogue of all our Jupyter Notebook resources. So the C3S ones are accessible, as you could see, from the home page of C3S. The ones for CAMS, for the Copernicus Atmosphere Monitoring Service, will be available on the website there as well. But at the moment, they're only available by, through the C3S Jupyter book, where we have a link on the left-hand navigation bar. But soon they will also be available on the training landing page of the Copernicus Atmosphere Monitoring Service, CAMS for short. So this is the website of CAMS. So atmosphere.copernicus.eu, and CAMS provides consistent and quality controlled information related to air pollution and health, so air quality, solar energy, greenhouse gases and climate forcing, and this is globally. But also here you can find regional high resolution regional data sets as well as global data sets. And very similar to C3S, the bedrock of this service is the data available on the through the catalogue. But I just want to show you also here, if you scroll down, you can find some very interesting pages. Okay, so for example, in the ozone layer, you find very good information about ozone monitoring. If you click on this page here, you can find very nice plots and animations of global ozone. Also quantifying the ozone hole. But then in the Jupyter Notebook tutorials, here in the Jupyter Notebook tutorials, you find very nice tutorials on how you can, for example, recreate some of these plots. So we have an ozone hole monitoring tutorial, and this will show you how you can use Python, how you can get the data for free. So the data, just like for C3S, if you scroll to the top of the page, and if you click on data, then you'll find a catalogue. Okay, so this is the Atmosphere data store. There's also another catalogue, but soon everything will be migrated to this Atmosphere data store. And this is very similar to the C3S catalogue for climate data, okay, which is called the Climate Data Store. This is for the atmosphere monitoring data. It's called the Atmosphere Data Store. And here it's a very similar catalogue to the CDS. And here you find all of the data sets listed here, and you can search, you can use the different filters as with the Climate Data Store. Okay, and similarly, you have reanalysis data from the past. You have predictions. You have forecasts for the future, for the near future. So this is more focused because this is focused on atmosphere monitoring. We have more forecast products for the near real time, not so much projections looking towards the end of the century. So this is more forecast data sets as well as reanalysis. And if you click on each one of these data sets, it's very similar. You see the overview page with all the different variables and the units. You find the data download page where again you can select the different parameters and you can download the data either by submitting the form or going to the show API request where you take the code and you can run it in a Python script. And then of course you have the documentation where you have the full information about that data set. So if we now go to the Jupyter book for CAMS, here we have the tutorial structured in a slightly different way. So instead of having a tutorial for each type of data, we have a tutorial for the kind of processing, the kind of processing you may want to do on that data. So it starts from data access tutorials on how to access the data from the atmosphere data store, and also how to import the data into Python, how to reduce it, maybe to take a subset or to do an aggregation, then how to export it. For example, if you want to export data from NetCDF into CSV, it shows you how you can do that. But these are using community tools, so just using Xarray, pandas. It just gives you some guidance on how you can use these community, these open source libraries for working with the data. Then we have a section here on data visualization. So it shows you how you can create maps. Let's have a look at that, how to create maps, how to create basic plots, also working with color scales, and multiple plots. It shows you how to create animations. So here you have an animations notebook. And we have some nice examples here. So this is an animation of dust, it's aerosol optical depth, or organic matter aerosol optical depth. And this is from the Dixie fire in California. I think it was from 2021. You can see the Dixie fire here and some other wildfires. And then you can see how the organic matter aerosol optical depth was transported across North America to affect air quality also on the other coast. Okay. And you can see that quite clearly in this animation. Then we also have a tutorial on time series. And here we have the example of CO2. You can see the classic Keeling curve. The time series of carbon dioxide over time. Actually, there's a mistake here. This should be CO. Okay, it should be CO. This is CO2. At least in the title, it's correct. I need to fix that. And then there's a tutorial here on creating profile plots and zonal mean plots. And this is for carbon monoxide. Okay, it just shows you how to create these kind of plots of the profile. So this is important to show that we have data not just in 2 dimensions, but also for different layers of the atmosphere. And we have data for different pressure levels, but also different model levels, which is kind of high resolution, vertical information. But the model levels, are slower access because they're archived on tapes. But the kind of slightly lower resolution pressure levels, we have them on the disks. Most of that data on the disks, so it's much faster access. So that's actually something important to point out, that in the catalog we have data. We have fast versus slow data. So basically, the data on the disks, that's fast data, and if you download that data, it should come pretty quickly. You may still need to wait before you can download the data, but it shouldn't take too long. Some data sets, so the kind of larger data sets, they're archived on tapes, which can be much slower to access. So you can it's still completely free, but it may take a very long time, even 24 hours, to actually download that data. So that's just something for you to be aware. But most of the data from these tutorials are from the fast access tapes. So they're very quick to download. So here we have an example of a zonal mean plot. And then we have some longer tutorials. So this is a tutorial on how to calculate the European Air Quality Index. So for different air quality indices. And we also have a tutorial on calculating the ozone hole, the Antarctic ozone hole. And this this just shows you how to create an animation of ozone, and then how to plot the ozone hole Okay, very similar to the plots you see on the CAMS website, which I think I had opened somewhere. I can't remember where now. Okay, maybe I closed it, but how to create a plot quantifying the extent of the ozone hole. So I think what I'll do now is I would just like to encourage you to really visit these go to these resources, use them, modify them to your own needs. So these are entirely free. They're very self-explanatory. So you find them, let me just show you again where to find them. If you just do a Google search for Copernicus Climate Change, okay, Copernicus Climate Change Service, and you'll find a link to it here. And then you go to help and support. So help and support. Okay, and then you go to training. And you go to training, and then here you have the Jupyter book, Jupyter notebooks. But I'll put in the chat I'll put in the chat directly the link to this Jupyter book. So let me do that now. So this is the one for C3S, and the one for CAMS is this. Okay, so if you click on these links, you find the Jupyter books containing the Jupyter notebooks, the Jupyter notebook tutorials for both the Copernicus Climate Change and Atmosphere Monitoring Service. I think what I'll do now is I'll stop talking and I'll open the floor to questions, to any questions you may have. So I know this training was a bit static in the sense that you know, I wasn't asking you to do things while I'm talking, because I think with a very large audience, it's very difficult to have this kind of engagement. But these, in any case, it's very difficult to listen and do at the same time. So I hope that you're able to follow my presentation, and I hope that you will be encouraged to visit these websites for CAMS and C3S, and to really explore, try out some of these tutorials and really, get familiarize yourself with this data, with this free data that is really, really useful, given that it's global. These are global quality assured data sets. So it's really a wealth of resources that you have freely available to you. So I think what I'll do now is I'll stop sharing my screen.
Hi, Chris. We do have a couple of questions for you from the chat. If
Great.
I may, I would like to voice the question to you directly.
Yes, that would
Sure.
be great.
So we have two questions about C3S and one question about CAMS. So firstly, about C3S, the participant would like to find out whether there is any information about the sensors used or the methods used to obtain these data sets.
Yes, that's a very good question. And the answer is yes, that information is available, and that information can be found in the documentation tabs of those data sets. So I can maybe give a very quick, let me show you. Just quickly share my screen again. Can you see my screen? Okay, so let's just go to the home page, just so that we start from scratch. So this is the Copernicus Climate Change Service. So you go to Climate Data Store, or you go to the data, okay, link here. Then you see the data sets. Okay, let's just go to one at random. You go to documentation. Okay, and there you go to product user guide. And here you find all the information about that data, input data. Okay, this shows you what data was used, what input data was used. So in this case, it's just ERA 5 reanalysis data, but then the ERA 5 reanalysis data in turn has a lot of input data. And if you go to that, the documentation of that data set, you'll find all the input data for that data set. So this is a huge data set. So it may take a bit of, I mean, there's a huge amount of input data used in this particular data set, but all the information is here.
Right.
I hope that answers the question.
Yes, and if you like, you could also copy and paste the link onto the chat so that the participant will be able to access this page very conveniently.
So this page, that's the input data for that very particular data set. But basically, for any data set, so for any data set in the catalog, any of these data sets here, each one has a separate link, and when you go to each of those links, then you go to the documentation, and there you find the full documentation, which tells you the data that's in that data set. Okay, so that there are lots of different links depending on which data you're interested in. But basically the data is available in the climate data store or the atmosphere data store. And you find them on the homepage of C3S. Let me put in the links to C3S and CAMS as well.
All right, thank you.
I'll put them in the chat. So that's C3S, and then CAMS is go to home. Sorry, it's to. And this is CAMS. Okay.
All right, thank you. I can see the links. Thank you very much. That is very helpful for our audience. Now, the second question relating to C3S. What's the difference between obtaining a data set through CDS API request and submitting a form?
Right. So the two ways of accessing the data. One is just to download the data. You click on the different little you click on the different checkboxes in the form, then you click download data. So once you've filled in the little checkboxes in the form, you can download the data directly, or you can obtain a script to download it programmatically. Now, obviously, to get that script, you had to, check the little checkboxes. However, once you have that script, you no longer need to check the checkboxes. Let's say you want to change some of the parameters. You want to change the variable, you want to change the date range, you want to change the geographic range. You can do that in the script without having to go back to the website and manually click with your mouse the different checkboxes. So the idea, let me just show you, let me just illustrate that. When you go to, let's just go to any data set, global reanalysis. Right, so in the download data, so here you need to select these different checkboxes depending on what you want to download. But then when you go to API request, you see all of the parameters are here. So you have the variable ozone. These are the different pressure levels in the atmosphere. This is the date range. Okay. Now, once you have this script, okay, you can just download the data here and you have the data. But if you want to change the, if you want to run a program that iterates through different time steps or different variables, you can put this into a script. For example, here you have, let's just go up to the script. This is how it looked. Okay, so here you might want to iterate through different years instead of having every year together, because maybe the data is too big. So the idea is that you no longer, once you have it here, okay, this error message just comes because I have I was running this tutorial in the cloud and this is now timed out. But once you have this in a script, then you can run this and you can iterate through different parameters of your data download. So I hope that answers the question.
Yes, that answers the question. Thank you so much. Now we move on to a question about CAMS. The question is, are we able to do a time lapse to show all data in one period?
So So all the data, I mean, we're talking about petabytes of data, so a huge amount of data, and this includes reanalysis data from the past. It includes also future data, so which is available, you know, whenever you want to start the forecast. You know, you want to initiate the forecast, and however long you want the lead time to be. There's always a new, you know, data set available. So if you want a time lapse of, let's say, all the data from the past, yes, you can do that. And the tutorials show you how you can do that. So they show you how you can create an animation of data from the past. And we even have on the website, we have some examples of, you know, time lapses, let's say. For example, I showed you already the ozone layer data here. So we have some animations that show the evolution of the ozone hole from the past. We have tutorials that show you how you can recreate those time lapses. But then, you know, we have so many different data sets. We don't have a single. I mean, it would be possible to have a single time lapse for all the different types of data, because we have data at different resolutions. We have data, you know, regional data, we have global data, but we have tutorials that show you how you can create a time lapse according to whatever parameter you set. Let's say you want to see the daily data, or you want to see hourly data, or you want to see yearly averages from the beginning of the time series. You can do that. So the tutorials show you how you can create those animations. But of course, we have some examples already provided on the website, such as the ozone.
Yeah, and I guess my advice to this person is that we need to understand what is the purpose of the analysis, and then define the variables that are most relevant to the analysis, and then only show these relevant variables in your time lapse. That will make it more you know, informative, rather than just dump all the available data on one time lapse. Okay, good. So the next question we have is about the precipitation data. Is the precipitation forecast data available on a global scale?
I believe so. I believe for precipitation, we do have that. I don't know the details of that particular data, but if you go to the catalogue and if you see the global forecast data, I think precipitation is one of the variables. So yes.
Thank you. And a general question, are there any tutorials that are friendly for beginners who are not accustomed with Python?
So the tutorials, especially the CAMS tutorials, they start very gently. So they really show you line by line what the code means. If you don't want to use code, then we have other tutorials, not for the Copernicus Atmosphere service, but for C3S, for the Climate Change service. We have e-learning modules that do not include you know, coding. They just explain what the different data sets are. They give information about, you know, seasonal forecasts, climate projections at a higher level.
Right, thank you. And finally, one last question. Can you give examples of work done at ECMWF? I guess we want to understand your activities or events that you have.
Yeah, so ECMWF, well, there's ECMWF, and then there are the Copernicus services entrusted to ECMWF. So ECMWF is an international organization that provides medium-range weather forecasting in support to the national Met services, the national Met services, who are member states or cooperating states of ECMWF. So that's really what ECMWF does. In terms of what we do, examples of what we do, so we do research. We have a research department. We have a forecast department. We also have a programs department, which includes management of the Copernicus services, C3S and CAMS. So yeah, I don't know if you want any more very specific examples of what we do on a day-to-day basis, but I can provide that as well if you're interested.
So I guess our participants, if you're interested, you can always visit the websites of CAMS and C3S to find out more about their activities and whatever projects that they are doing. And just one last question, more about general housekeeping. Some of the participants are interested to find out how they can receive a certificate of participation for attending this webinar. So I would answer to this participant. Please send us, write us an email with your name if you would like to obtain a certificate of participation. So I guess that's the end of the Q&A session. Thank you so much for your time. I'll hand it over to Chris and Natalie.
So yeah, I guess just thank you very much also from my side. I hope this was interesting for you, and I hope you have been stimulated to really go to our websites and check out these resources and use them. And if you have any problems, please contact the user support, and we'd very much like to hear from you.
Thank you very much, Chris, again, for this wealth of information. And to our attendees, please feel free to consult the webpage. There is really a lot of information there. There's also a lot of information available about Copernicus and the Copernicus services. Just one final word. So for those who would wish to receive a certificate, please just send us an email with your name to the UNOOSA event email. This is the email that confirmed to you that you were registered for today. And then we will check that you had attended, and then we will send you the certificates. Again, Chris, thank you very, very much. That was really very interesting. I mean, I learned a lot of things, and I hope our participants enjoyed it as well. We still have 2 trainings that we still provide, one next week with EODC, and then in 2 weeks we will have a live Q&A with the trainers from NASA. The NASA training is already available online. Please have a look at our webpage. You'll have more information about the trainings to come, and you can still register for them. So once again, thank you very much for joining us. Have a good morning, afternoon, evening, wherever you are, and see you soon. Bye-bye.
Thanks a lot.